What's going on, everybody? Got another video here for you. Alright, so today what we're going to do is we're going to do a double integral. I did one last time. We're going to do another one and change in the order of integration. So you can see here, if we wanted to try to integrate this one with respect to x first, that would be very, 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 very difficult. So let's look at changing the order of integration. We want to integrate with respect to y and then with respect to x. So let's do a little sketch here. So you can see here for these bounds on this outer integral, that is y equals 1 and y equals e. So if we sketch that, let's do that over here. If we sketch that, here we would have, let's draw that in red. Here we have y equals 1, and then we would have y equals e. Okay? And then for the bounds on the inner one, we have x equal natural log y, and we have x equal 1. So if we look at this x equal natural log of y, that means e to the x is equal to y, right? If we convert it to exponential form, this graph would look something like that. All right. And then here we would have x equal 1. This would be x equal 1. All right, so what we want to do is we want to set it up where we're integrating with respect to y first and then with respect to x. So let's look at the y. So we got cosine e to the x minus x, and we want to do dy dx. All right, so if we integrate with respect to x, I'm sorry, with respect to y first, we're going from here to this curve here, right? So we're going from y equals 1 to y equals this curve right here, which y is equal to e to the x. Now let me change colors. 1 to e to the x. And then for the x values on this outer integral, we're going from 0 to 1. So here we're going from 0 to 1. All right. And now we integrate. So if we integrate this is going to be 0 to 1 y cosine e to the x minus x, and y equals 1 to e to the x dx. Okay? Because remember, when you're integrating with respect to y here, this cosine e to the x minus x, that's a constant. Okay? And so when we integrate, we get y times that constant. All right, so now this is going to be 0 to 1. Now we plug the e to the x in, minus, and then we plug the 1 in for y. All right, and times that constant, dx. All right, so hopefully now you can kind of see, what's going on here. How we're going to integrate this. It makes it a lot easier. But yeah, whenever you evaluate this, you take the e to the x, plug it in for y, take the 1, plug it in for y. And then this is just a constant, and that constant's multiplied to that. All right, so now, how do we integrate this? Well, we use u substitution. So we've got u is equal to e to the x minus x. All right, and then du is e to the x minus 1 dx. And so you can see here the e to the x minus 1 dx, we're going to replace that with du, and then the e to the x minus x, that's going to get replaced with u. So this is going to be the integral of cosine u du. Now, remember, we changed our variable, so that means we have to change our bounds. See, these bounds here, that's in terms of x, but now we're in terms of u, so we need to get these in terms of u. Whoop, I accidentally opened something. All right, so now let's do that. So remember, to change your bounds, you've got to take the 0 and the 1 and plug it in here so we can figure out what u is. So here we've got u is equal to e to the 0, e to the 0 minus 0, which is 1 minus 0, which equals 1. So that's going to go from 1, and then we plug the other one in, u equals, so let's see, in the place we're going to put 1 in for x, so that's e to the 1 minus 1, which is just e minus 1. And so that's going to go to e minus 1. And so now we integrate, so that's going to be sine u from 1 to e minus 1, which is going to be the sine of e minus 1 minus the sine of 1. And then we plug this into our calculator, and we get 0.14767. We'll just round it to that. All right, so one thing that you've got to remember, though, is when you punch this into your calculator, you have to make sure that your calculator is in radians. Okay? Your calculator has to be in radians when you plug that in. So there's your little example of how to do a problem changing order of integration. All right, so I hope this was helpful. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.